I'm going to give it to you is the understanding related to database security concern to make you in frame and to make you be aware of what this course is about. To give you one start off and one kick off, uh, and then after we'll tackle the unit number one. In this full course, actually, we are going to tackle the security related to projects that they enhance the use of databases in general. So we are not going to secure the database by themselves as per the generation of database only, but in addition to that, we are going to guarantee that the projects that they enhance the use of database, they are secured also. Transactions, they are secured also. Um, Inter processes that they actually share resources or back-end resources, they are secured also. So it is a complementary view or overview via which we secure the full framework where database they are integrated, wherever they are integrated. It is not only just a database, a DB, its security and stop there. No, it is a full overview that secures all the transactions related to the use of databases. Our framework is related to Microsoft only. We are within the Microsoft product. We are with the let's say Microsoft technology. This is not a constraint, but we are having a reference, and we are going to follow it step by step. We'll try to accomplish 9 units fully. We'll try to accomplish 9 units. The unit number 6, 7, 8, and 9. They are actually portions we are going to cover from each. We are not going to cover fully, but even though they are giving us extra knowledge. Let's get started. Bismillah ar-Rahman ar-Rahim. So the unit number one is tackling the concern of the APIs, application interfaces, via which we try to get connected to a database. So the first preview here pushes us to understand that we are going to work remotely with databases. So we are going to tackle the database in question from an external and remote interface. We are not going to deal with databases from within the database itself. No, we are going to use external APIs, dedicated APIs, to connect to database. The first one is the SSDT, SQL Server Data Tool. It is an interface via which we are going to successfully connect to a database, a Microsoft database engine, and guarantee all the functionalities to be running smoothly. The SSDT, remember the word, SSDT. So the SQL Server Data Tool is the main concern of this unit number one, but at the conclusion we'll be able to understand that there are different APIs, interfaces we can utilize to achieve the connectivity to databases, database engines remotely. The index of this unit, briefly, actually we are going to go all through all those outputs. So the first definition we're going to tackle here is the definition of what is the SSDT. As I said earlier, it is an API that helps us. The SSDT SQL Server stands for SQL Server Data Tool. It is actually it is a software, kind of a software. It's a tool that we can install. It is a Microsoft product only that helps us to get connected to a database engine. No more, no less. So we are going to segregate the work with databases remotely. So we give an interface, a layer that helps us to use all the functionalities from within the DBMS database management system, but remotely. This SSDT actually it helps us to enhance the let's say the exposure and the use and the to impose the use of new technologies safely. The first technology to define here is the TSQL. We are not going to deal with the regular SQL as usual. We are going to modify it a little bit, and literally we are going to utilize this SQL, what we recognize or what we know earlier, relate to the thing nominated as SQL for transactional purposes. TSQL, it would enhance that. So the SSDT is an API that would actually gives us a tooling interface that we can utilize the available predefined functions from within the SSDT itself to enhance extra functions, extra functionalities, sorry, using what you call it here TSQL. Actually, here, first conclusion, we know that the databases they can understand the unique structured query language, which is the SQL, uniquely. They do not have any chance to deal with any other programming language to receive requests or to display or to send responses. No, only the SQL. Only the SQL. So the SQL is, and it is actually, it is validated. The SQL, the SQL, is unique tool to communicate with DBMSs or with databases. DBMS or DBs. They are all questioned to be communicated with or over the SQL only. What we see here, the TSQL, is an extra feature that actually it's an addition, it's an added value that we're going to utilize on the basis of the SQL itself. We are not going to eliminate the SQL. No, still the SQL is still, we are going to use the SQL only. Yet with extra functionality, with added values. We are going to modify little is saying we are going to utilize the SQL differently from within different bodies. We're going to integrate it inside other blocks to secure all the query responses, whatever, client server request or server client response. All of them, they are going to be secured by utilizing dedicated bodies from which we integrate the SQL queries. In plural, SQL queries. Yes. So the TSQL is the technology that yes answers this point. So what we are going to answer here is implemented using the TSQL, the transact SQL, no more, no less. So the conclusion here, the SSDT, it's an interface that gives us a rich tooling interface. What does it mean? Means actually it's an interface that gives us a list of tools predefined that we just utilize them like they are. Click a button, drag and drop, just call the method, whatever. They are ready, you just utilize. It depends on the scenario you are in or the block you are in or the step you are in. You just utilize the available tool for your dedicated or your concerned function. The first concern here, before I pass on, the first concern here is that why we are talking about ready-made tools, why we are talking about bodies to surround SQL queries, and why both? To avoid one security concern, which is the interference. Actually, the interference or the inference, all the terms are correct here. What I'm highlighting right now. What does it mean? Actually, a list of queries, they might be actually dedicated to one process. List of queries. List 2, 3, 400. List of queries, they might be dedicated to only one process. If they have been interrupted for a reason or another, the full process fails, which might cause problems in the overall project process, where the transactions would actually half will be executed, will be actually deducting values and numbers, modifying values which are actually causing a disbalance, whatever. The interference does not have to happen within one process body. It has to happen in between processes in plural, but not from within one process. the TSQL bodies that they englobe, or let's say they surround, or they are the body, or the bodies in which we integrate the SQL queries. They are capable of blocking interferences. SQL themselves, they are not. They are simple queries to pass. Either you execute or not. So they cannot, the SQL by themselves, SQL queries, they are not designed to either allow or deny the interferences. They do not do this task. They only pass a query or retrieve a response. That's it. To control the interferences, no, this is not their role. The TSQL, yes, this SSDT with its predefined tooling, let's say library or group of libraries, in addition to the deployment of the TSQL, we will have a strong, let's say, solution, but is capable of blocking the interferences. In conclusion here, actually, to make you understand, I put you into a situation by asking you a question. Try to understand the question, please, and tell me later on if you are able to answer it or not. The security versus actually to sorry, or the fraud or the threat or the risk or the vulnerability that we may, or in plural, vulnerabilities that we may face when passing a list of queries to accomplish one process. What are they? What are the issues? Might be what is the issue, singular or plural, that we might face when we pass a list of queries to execute or to terminate one process. Can you answer the question? Is it clear, please? جهينة كيف حالك؟
Yes, Mister. Alhamdulillah.
Afra, what is the
What was the
answer of the question? I said, if we pass to a database a list of queries to execute or terminate one unique process, what is the, let's say, the vulnerability that we may see based on what we explained, based on what we explained so far?
and the database?
Hey, what is the vulnerability we can face? What is the concern of security here? Interference. غدير موافقة أو لا؟ Are you with me?
Yes, Mister.
غدير, are you here? غدير, the question is to you. So here, just here, be with me. Try to wake up. In conclusion, here, just let's close this point. The integration of this new, or let's say this approach to utilize remote interfaces to connect remotely to databases, to utilize interfaces to help us connect remotely to databases, yes, and the use of the TSQL instead of the SQL, there are reasons in plural behind of that. We actually, as per this level here, the book, actually, the author pushes us to understand that when we have a list of queries to execute one process, the interference is a problem. The interference or the inference or or interfering those queries is a problematic situation in the sense of, for example, if we have 10 queries, select, insert, select, insert, update, alter, they are queries to finalize one process, whatever the process is. Money withdrawal, profile update, companies, whatever, detrin, or let's say truncating or whatever. The interference is a problematic situation. We have to accomplish all the queries to say that the process is finished. Otherwise, no. So to avoid interference of those, to avoid interfering those queries before they finish, we have solutions also, not only one solution. We have to refer to the technology that the TSQL enhances using the predefined tools available within the SSDT API. And this way, we will be able to, at a level, guarantee that the interface is controlled. It would not happen. It would be controlled for sure. This is actually very clear understand, and we can clearly describe that. But is it feasible to implement on real world? No, there are challenges. We will not be able to implement that clearly. Just 1, 2, 3 steps and finish. We did it. We implement and we guarantee that the interface won't happen. No, there are challenges. There are challenges. From the challenges, actually, we will be able to just list them, but we will see them one by one because the challenges, they are numerous. The first thing, actually, it is related to the SQL themselves. So only the dependencies or the referential integrities, they are one of the concerns that we have to tackle. The dependencies and the referential integrities, they are one of the concerns that we have to consider when building a TSQL body, when building a TSQL solution to englobe a list of queries. Yes, because referential integrities, they are capable to relate external parties, which they have actually to give us, and which they give actually an access point to the body of the generated body, the TSQL generated body. You have to clearly understand what is the referential integrity, what are the dependencies, what are the constraints, in order to understand what does it mean actually, what this challenge value. Another concern, which is a challenge also, the runtime errors, the late error detection, or the runtime errors. The exceptions means the late error detection or the runtime late error detection or the runtime errors. They are errors that we will not find or detect. Developers won't find or detect unless they deploy the solution. It is said like that, runtime error. So the system has to be running in order to detect those errors. This is a challenge. At the time, we have to find a solution and to be ready, not to stop the service, but to fix the errors somehow. So this is another challenge. The deployment and whatever the updates or the upgraded scenarios, there are other challenges that we have to tackle also. So the system we are going to deploy today, it won't be actually feasible after 1 year or after 2 years or even after 1 month. It has to be updated usually and upgraded to the new available technologies on the market. Otherwise, it would be deprecated. It won't be feasible to be utilized. Any questions? If you have any questions, you may interrupt me, please. I won't go fast. No questions. Okay, that's great. So when you don't ask means I can understand that you understood what this speech was about. So that's great. So we continue actually, and we still talk about the SSDT only. The SSDT is an API that gives us actually a very rich experience. It's not a rich experience. It gives us a very rich experience that can help us as developers to easily implement different functionalities, whether to implement as a TSQL bodies or to implement dedicated security procedure or solution, whatever the solution is, the availabilities, the tools available, or the tooling design available inside the or within the SSDT helps us to develop a very rich solution because of the rich experience that we have from whether the use of the SSDT itself, the SSDT body. The use of the SSDT, now you have to know that we are going to implement whether an on-premise or local DB or an offline DB or an on-cloud or online DB. There are three models of databases that can be integrated from within a project and can be actually controlled using the SSDT. The on-premise or local. This is the first. An offline. This is the second. Offline database or an offline based database used. Or an on-cloud or online. Number three. I started with those two, that I came back to the online. On-premise or offline, they are actually 1, 2. Then after I came to the cloud. They are not ordered. They are not ordered. Those are models of databases that can be actually integrated from within a project. But they are not ordered. This is the first, this is the second. No. Just I'm reading them this way, just to explain easy later. The on-premise or the offline, they are two categories via which we see databases used for development, basically, not for live streaming. In the sense of, we can use a local database or an offline database to develop, to enhance, to modify, to add, to delete, to alter, whatever you want to do. Nothing would be seen by the end users. Let's take the example of the EduWave. Usernames and passwords, they are stored somewhere in the background, and all of us, we can use the EduWave username and password fields. Okay, the technical or the administrators of the EduWave, they are planning to add a second password to use. Let's make it easier. Okay, you have username and password, and you have to add a second password for more security. Password number 1, password number 2, second factor for authentication. What should we do? Do they have to test it successful or not on the real plane? No, they have to do it in background. If successful, then students will see and faculty will see and so on. So what they will use the on-premise or they will use the offline mainly database. If successful, they will move to the online or on the cloud database. Is it clear? Because of this only, what I'm bringing your attention to is that the SSDT, the SQL Server Data Tool, can help us to deal with different types of databases or different types of database-based projects. There are three mainly, and they are completely different. Let's have a look at this graph. No, before I go to the graph, there is something that you have to recognize before we pass. I asked you if you have any questions. Still, I persist on that. Great. Since you don't have any questions, the context of, I was giving you the example of the EduWave and the second password, and if they test it on the offline database, then after they have to deploy it on the online database or to the on-cloud database. How they will do? Do they have to stop the full service, the full, let's say, project, and they bring the new database, the offline one, to the online, and they tell the students and the faculty, please wait for us 1 hour or 1 day or whatever until we update? No, it has not to happen like that. The system has not to fail. So the off time has to be 0. The off time has to be 0. What does it mean? It means actually the database has not to be stopped. The system has not to be stopped, but has to be upgraded or updated while running. It has to be like that. So what solutions are available to do so, to implement this approach? There is a technology which is actually enhanced using two, let's say, as tooling capabilities that the SSDT gives us, stands behind the use of the change script. And this change script would actually test, usually, if there is any changes between the offline database and the online database, or between the on-premise database and the online database. If yes, so the system, this change script will take the updates only from the offline to the online, or from the on local or on premise to the online also. The change script. The change script will use actually tools to compare. It will compare the offline to the online, or he will compare the on-premise to the online. The change script. Once he finds modifications, he will make the updates only. He will not stop everything and take the offline one to the online. No, he will only update the modifications only to the online one. By doing what? Whether simple create query or alter query. Simply. So the change script is the solution that the TSQL enhances to go from an offline to an online status, or from a non-premise to an online status without off time. Using the create or alter statements. Create if the object is not completely available, is not existent completely. Alter if the object is available but there are modifications. Create query and alter query, they are SQL, simple SQL queries now. And at this time, when we do creation or we do the altering activities, the dependencies, they are respected and they are considered. And actually, there will be usually comparison between the prior offline and the current offline, in order to say that there is a change or not. Any questions, please?
No.
Okay, remember the word change script. We'll come to that frequently. Change script. Okay, here we see a visual graph to all what we were explaining. Here which we see the SSDT on top. The SSDT is remotely connecting to the project that uses a database. We will be having three types of database. One of them is going to be utilized at a time. Means we're not going to utilize the three of them, but each is for a purpose, for a dedicated purpose. The local one actually is the one to create on a local computer to utilize as if it is live, but it is on local framework or local environment without any constraints that it is offline or online. It is one of it is said to be on premise because running on the local device. And mainly we talk about local framework, local environment also. The offline one, it has not to be utilized for public, but it has to be dedicated for, let's say, implementation, development, and test purposes only, the offline. The one we see in left, whatever the version is, but all of them, they are enhancing the offline. And the online one is the one that gives the output, and it gives actually the service to the end users, to the clients. Okay. When we said earlier, let me come back one step before. When we said earlier that the chain script is a technology that actually we have to refer to in order to check up if there is any modifications between what? Between the offline database and the online database, or between the on-premise database and the online database. Then after we do the update, how it would happen actually? The change is going to change script is going to compare between what and what? The online database and the offline database? Never. The online is a live database. You cannot control it actually. Sometimes and in majority of the cases, it is distributed database. So it's not something to handle from within a simply saying that we're going to compare an architecture using whatever technology you deploy. You'll fail. In so many cases, you'll fail. So we are going to, usually, or the chain script in our case is going to compare, and I said it, in between an old version of an offline database with a new version of an offline database also. New and old based on time points. So we are going to compare the version of today to the version of the next week, or we are going to compare the version of the last month with the version of today. So based on two time frames, we are going to compare the same database type that was utilized to implement or was utilized to develop. If there are modifications, then the online one is going to be updated using this chain script, the same chain script. Also here, the database utilized to generate the chain script is not going to be compared by itself. The solution that the TSQL enhances here is not going to use the database architecture itself, but is going to generate a copy. It is nominated snapshot that takes a sample from all the objects inside the database at a given time frame. After a while, after 1 week, after 1 day, after 1 month, after 1 year, when the test is going to come, another snapshot is going to be generated, which is another overview of the database in question that holds a copy of every object inside the database. I repeat, it holds a copy of every object from within the database. Then the two snapshots are going to be compared. Snapshot 1, snapshot 2. If there are changes, immediately an update is going to be set on which database, the offline or the online? The online one. Snapshot to be generated from an offline database or a non-premise database. Two snapshots. If they are different, so the online one is going to be updated using the chain script itself. And the update, I come back one step, it is the context of creation or alter, create or alter statements. Simply. Is the chain script to take care of that. It's the change script to take care of those updates. So the snapshot, it is a sort of an overview of the database. It is a one file that has a representation of every object from the database in question. Let me just go one step further in order to bring your attention to is that. I'll come back. Just give me a chance to retrieve the information. Data tier application component package is the extension of this snapshot. Well, what the change script is going to use is the snapshots. What are the snapshots? It's an overview of the database that has an extension. It's a one file. The extension is DACPack. DAC stands for data tier application component package pack. DACPack file. Two DACPack files or two snapshots. They are going to be utilized by the change script to compare. If there are modifications, so the online one has to be updated. Otherwise, no. I'll stop. Any questions, please? Any questions, please? If you have any questions, you may raise. Otherwise, I'll take the attendance.